Okay, we've made it to our last day of this chapter. We're going to talk about some integration techniques, like I mentioned. And we talked before about how, derivatives are pretty straightforward. We've got a number of rules that you can follow. As long as you follow those rules, you can take the derivative of anything. While integration, there are many, many, many different techniques that we've seen so far, and many, many, many techniques that we have not seen and will not see in Calc 1. But I'm going to give you guys kind of some tips as to what method you should use. And the thing that's a little bit tricky is that the methods are very different from each other. And even the slightest tweak in a function could make you use a totally different method. Okay, so I'm going to give you some advice, kind of some tips. So this will be just a nice little short set of notes. And then we're going to do a lot of integration practice in class. Okay, so this first one, if the integrand is in this form, you've got f of g of x times g prime of x. Hopefully you recognize that as like an undoing the chain rule type of form. Like, and then we show these two, so there's an x squared plus 2 in the denominator. And the derivative of x squared plus 2 is 2x, and we've got a constant multiple in the numerator there. Or maybe you have tangent u with u prime somewhere in there, or e to the u with u prime in there somewhere, or 1 over u with u prime in there somewhere. If you see a nested function and you see a constant multiple of its derivative somewhere in the integrand, we do what we've been doing for the last couple of days. You make a u substitution. You make a u substitution and balance the coefficients if necessary. All right, so it might be beautifully set up that u prime is in there perfectly. Something like this, it's not. If there were 2x, it would be in there perfectly. But we have to balance out the coefficients a little bit, meaning you play around with like the du dx until you get the right constants. We've been doing that for the last few lessons. If the integrand has a nested function, its nested function is x plus 4. But I guess this is worded kind of weird. It's not that its derivative isn't there, because its derivative is 1. Let's say there's something extra besides the derivative. What you do with this is you make a u substitution, just like you would with the other one. Then you actually make a secondary substitute. You substitute in for x. So I'm giving specific information for this integrand. So for example, you'd make a sub for x plus 4, but then you'd say, all right, well, what's x? Well, I guess that means x must be u minus 4. And then you simplify as necessary. We saw a handful of these examples where once you get this far, you need to simplify up quite a bit. Okay? If natural log is anywhere in the integrand, this is a really good tip to kind of keep in your back pocket. All right, so if natural log is anywhere, almost every single time, no matter what, the substitution that you're going to make is for the natural log of x. The reason is, and I want you guys to write this down too, we don't know the antiderivative of natural log yet. So because we don't know what the antiderivative of natural log is, we can't have it left in the integrand because we don't know how to integrate it. So you always have to sub it out. Now there is an antiderivative of natural log. It's just not something that you would learn until Calc 2. Okay, so that's a tip. If you see natural log, that's very likely going to be your u substitution. Okay? If the integrand is a rational function, now this is one that we haven't seen yet, but it's one that we're going to be practicing with some of your practice problems. If the integrand is a rational function where the numerator has a larger degree than the denominator, this one for instance, or this one, x squared is bigger than x cubed is bigger than x squared, you are going to, or I'm sorry, whoops, I meant to, oh no, I did mean to leave that there. You are going to divide numerator by denominator. I thought I meant to have those in two separate categories, but no, I can definitely put it in the same category. This one is a little bit simpler because you just have an x. So like this one, for instance, what you would do with it is you'd split the x squared over x and then you'd split the 2 over x. For some reason, this is one technique that people forget about all the time. When you're doing antiderivatives, when you're doing derivatives, this one would be a little more complicated. You'd actually have to do either long division or synthetic division or something to divide it up into pieces. And then, like I said, when we're doing some practice problems, I will kind of get down into the details of how you would work on something like that. Okay, if there is a quadratic in the denominator and there's a constant in the numerator. So normally you'd think like, oh, if there's a quadratic in the denominator, it must be a u substitution, but there isn't an x in there anywhere. So if there's a quadratic in the denominator and a constant in the numerator, then it's probably going to fit into the form of tangent inverse. So somehow, some way, you're going to make some sort of substitution and get it to fit in with a tangent inverse. Or, very similarly, like we did in the last lesson, if there's a square root in the denominator and it doesn't fit a normal chain rule pattern, like this one doesn't fit a chain rule pattern because you don't see an x anywhere in the numerator. Same thing with this one. If you see an x in the numerator, it fits a chain rule pattern. If it doesn't have an x in the numerator, then it's either going to be secant inverse or sine inverse. And you might have to do some crazy substitutions like we did in the previous lesson to get it to fit with what the original pattern is, okay? One thing that I need you to keep in mind, and this is the last thing we've got in the notes here, please remember, you might have to try a couple things. Integration is way trickier than taking the derivative is. You might have to try a couple things out to get something to work. The big thing that I want to keep you to keep in mind for my tests and for the AP test, you will never be given something that you can't integrate. I mean, if you like flip through the book and you were looking for random problems, you might come across something that you can't integrate. But I will never try to trick you. So there is always something that will work. You just might have to try a couple things. So hopefully the sheet will be helpful to you in giving you a couple of little tips and tricks. All right, so very, very record-breaking short notes for you today. And that's the end of this chapter.